Alright fellas, let's stop messing about and get this thing fired up. Good plan. Now, just to quickly catch you up, because I have done a bit between videos. Those of you who are following along will recall that we had a chipped piston ring out of the box. At the time, all I could get locally was a plain cast iron Brit part ring, so we assembled the motor with that. Since then, I did get the correct chrome ring from Turner Engineering in the UK. They just sent it out, so thank you for that. And that's all been fitted, so sump off, piston out, new ring on, and everything is now back together. So the internals are all buttoned up for good. Now it's a case of getting this thing running. And we're going to start by setting the valve clearances. So first, we are going to do number 1 tappet when number 8 is fully open. So this is number 8, unsurprisingly. So there, you can see number 8, that is fully open. And you can just eyeball that. You don't need to measure it or anything. The reason for that is because we know that if number 8 valve is open, we know that number 1 valve is right on the back of the camshaft. So there's no chance that number 1 valve is partially on the slope towards opening. And you can see that it's loose. So this is 10 thou or 0.25 millimeters until it starts to drag, which is right there. Can be a bit fiddly to tighten the lock nut without further adjusting the valve, but you'll figure it out. Okay, a little bit of drag, good. Next, number 6, it's about fully down, so now we'll check number 3. Okay. Easy. And I'm not going to show you all 8. You get the idea. Let's move on. So I'll just quickly degrease the gasket surface, because these new style ones are a giant sticker, which is pretty cool. Whoever thought of that was a bit of a genius, because before you had to do this awkward sort of half tighten and tuck it in, and now we should just be able to stick it down, I guess. Oh, it's good to know that it still doesn't fit very well. Okay, maybe the stickiness is a waste of time. Great. Now, this is the rocker cover that has been living on this engine. We're not going to use this rocker cover because you can see this nasty cast line running right through it. I guess quality control was on strike. I don't know, but this should have gone back into the remelt bin. I've got a better one. Hang on. That's a little nicer. Okay. Now, in fact, what I'm going to do before I tighten this down is put a smear of grease on top of this gasket. And this is to stop the rocker cover sticking to the gasket, because we want to be able to take the rocker cover off without destroying the gasket. You need to get in here for maintenance, and it does not need to be glued down. Yes, I appreciate this is a thick smear of grease. I'll get the excess off in a second. Okay. Just like that. And new rubber seals, just replace these. I don't know how much these are, but they're probably about 10 cents each. So just, if you're ordering anything else Land Rover related, get a new set of these at the same time. They come in the gasket set, by the way. Oops. Okay, now the little caps currently have wet paint on them, I think. Yeah, they're kind of not really dry, but well, let's just put them on anyway. And next, I've got a little treat. How about some brand new in Land Rover packaging old stock acorn nuts? Because if you have to buy these new from Britpart or whoever, they look nothing like the original ones. And they're surprisingly expensive too. There we go. So those are just touching. We're just starting to put some pressure on the rubber now. And this is what we're going to do. What size are those? Why does my 1/2" wrench not fit these? Where's that packet gone? 247121. Where are we? 247121. Yeah, okay, that's the correct part number. Don't know what's going on here. These should take a 1/2" wrench. Maybe there was a mix-up in manufacturing. That might explain why these ones were never used. Don't know. Okay, anyway, where were we? Okay, so this is now, you can see, just starting to squeeze. That's it. Okay? That's all we need to do. Let me show you something. See this metal cap? See the rubber seal? See how this is about half the thickness of this? You don't need to squash this all the way. Stop doing that. Use the squishiness in the rubber to put pressure on the cork gasket without crushing everything to oblivion. Just like that, and that is not going to leak. The next logical thing is to fill up this hole. And that is what we're going to do, but first, a little explaining. So this vented cap is part of the CCV system, Crankcase ventilation, and that applies right from Series 1 through to Series 3. I'm not going to explain the differences right now, but the important point is that you need to get this right. I've got mostly Series 3 parts, which is either this system with the little T-hose or this system with a PCV valve. Now this particular engine has already been sold, and it's going in here. Currently fitted with a 2.25 litre engine from a Series 2 by the look of it. Now this guy is going to want to run a simple 2-vent system like this rather than mess about with all the pipes and stuff. And I'm not going to go out and find Series 2 vent caps because he already has them, and he can just put these ones on when the motor gets to him, hopefully after a quick spray of black paint. Anyway, the point is we're going to start the engine up with the Series 3 vent cap and oil fill tube because those are the parts that I have here, and I'll just leave them open so it runs like a 2-vent system on earlier models. And he can put the right parts on when the motor gets to him. Alright, let's do something fun. Let's put the ignition system in. First thing we need to do is put the engine at top dead center. Okay, there we go, top dead center. 6 before, 3 before, 0 and 6 after. We want 0 for this engine. Now if you are setting up the low compression engine to run for the first time, you would put this mark at 3 degrees before top dead center. Now this being a 4-cylinder 4-stroke engine, both piston 1 and piston 4 are at top dead center. One of those pistons will be on the ignition stroke and the other will be on the exhaust stroke. What we need is to make sure number 1 is the piston on its ignition stroke. And if you're a bit of a geezer, you can take the spark plug out, hold your thumb over the hole while somebody else turns the engine, and when the gas is pushing outwards, that's coming up to its compression. But otherwise, the easiest way is to just quickly take the valve cover off. Like so. Oh, now you're stuck on. We didn't use enough grease. Oh yeah, there we go. All right. Valve cover off. Here are the valves for cylinder 1, the valves for cylinder 4. When a cylinder is firing, both valves are closed because the explosion needs to stay on the inside. And we have 10 thou of valve clearance when a valve is closed. So if the rockers are loose above cylinder 1, that'll be the cylinder on its ignition stroke. If the rockers are loose above cylinder 4, that'll be the cylinder on its ignition stroke. And it so happens that the rockers above cylinder 1 are the ones that are loose. Okay, so that's what we want. Let's put that back on. Okay, so this grubby old thing is the distributor that was on this motor, and it's probably the one that came from Land Rover on this motor. It's a Lucas 25D, which was used up until the mid-70s when it was replaced by the 45D. Now we are not going to use this distributor for 2 reasons. Firstly, it's old and dirty and I don't need another side quest right now. And secondly, you guys are always harping on about electronic ignition. So here we are. What is this thing called? Power Spark. That's the brand that all the Land Rover people get. And it's the same shape as the 25D Distributor. In fact, you can get this from the same company with points as basically a replica. But this one has the electronic ignition kit fitted, which is just a Hall effect sensor, basically. I personally don't really rate these, just because they're aftermarket parts and there's nothing wrong with points, but not that I'm saying electronic ignition isn't superior, because obviously technology tells us it is, but points work fine, and I personally would prefer the genuine parts. However, most people prefer this, so we're going to fit one of these. See how it goes. Now, the interesting thing about these electronic distributors is I have no idea how you set your static or initial timing. And in fact, the instructions just tell you to eyeball it. So if you're going to install one of these, you're going to need a timing light. And of course, your gasket set will come with a new gasket. Normally both options, a paper gasket or a traditional tin. Sometimes you actually get a really nice, sticky, thick gasket to go in here. But in this case, I got the tin and the paper, and I prefer the tin just because this area is not really prone to leaking. And if you use the tin one, you can take the distributor on and off without having to worry about replacing a gasket each time. And of course, I have a nice, freshly cleaned base. Just sit in there. And we now have to put in our infamous little adapter piece. I'm not going to talk about that in this video because you've already seen me talk about that at length. I'll just put some grease on the bottom so it sticks in place. Doesn't come out with the distributor while we're playing with that. And in she goes. There it is. Approximately lining our small half up with our small half. This should now just drop right in. Oh, there. The slot at the bottom of the distributor happened to line up perfectly. Otherwise, you just take the cap off and turn the rotor until it drops into place. That's where that's going to live. Then we'll just install the little screw that holds the clamp down. Now, there is a bit of slop in this screw hole too, but normally you loosen the clamp. Now you see we can turn the distributor. All right. There is the inside. Oh, I do not like how that's facing. Long story short, I don't like the way this distributor is aligned. This is all about the alignment of the drive gear, which I discussed at length in part 7. And apparently, this aftermarket distributor is not clocked the same as original Lucas ones. I don't know if that's a quality thing or maybe catering to lots of different vehicles. I don't know. But anyway, I don't like it. And the only way to fix it is to pull the drive gear out and move it one tooth clockwise, which is what I did. All right, so that's all sorted. Let me tell you a quick story. Bring it in. Do not use the low strength Loctite on the set screw. It's a little too much. I mean, I did manage to get this one out, but as you can see, it was looking pretty marginal there for a minute. Apparently low strength is not very low strength. I mean, of course the answer is to buy a new screw and then you have the nice original locking strip. Or in this case, this is another second-hand screw I had lying around. I just put a very small dab of thread sealant on it because this never goes hard. And I would also point out that in the past I've done absolutely nothing. I've just put the screw back in and never had a problem. But there is enough of a space here for this to potentially back out. And I think if it backed out, what is that, about 3 millimeters? That could cause carnage. I do think it's prudent to do something to kind of secure that screw. The other thing you could do actually, which maybe I will do, is just put a dab of sealant in here. So when the oil filter goes against it, there is no room for the screw to back out. And yeah, the next guy's going to have to pick it out with a pick before he can undo the screw, but you know, that's not a big deal. Aside from that, we are back where we were, except now we have the rotor pointing in a slightly better direction. I would have kind of preferred it to be in between, but we don't have that. We had either up here or now down here. And I think it's going to put the distributor sort of like this, which is good. In fact, you can see here there's a mark in the case, and I would assume that that is where the number 1 post is. And that is how we are going to set our initial timing. That is the only way we can do it. Line up number 1 post, which I think is represented by that little mark, with the center of the rotor, and then see where we are when the engine fires. And then we just tighten up the clamp. And there we go. That is our timing set, at least, hopefully, close enough to start the engine. On a traditional points-based distributor, you'll get it really close doing the static timing. On this, we'll just have to wait and see. We're guessing. Alright, starting to look like an engine. Okay, I forgot about the flywheel. Alright, we are not finished. I thought we were 1 cup of tea away from firing up the engine, but no, there's a little bit more we have to do on the flywheel first. Alright, so this is the flywheel that came... No, it's not. This is not the flywheel that came on this engine. That one was mangled. This is another old flywheel that has been resurfaced. So from that point of view, it's very nice. Now, these flywheels have 3 alignment dowels in them that have to be removed prior to the flywheel being resurfaced. The Land Rover ones are known to be tricky because the dowels are tapered, and the collet puller that machine shops use doesn't grip them. So they had to drill them out, and there's a little more wallering around the top of the holes than I would like. In saying that, I think the dowels will go in fine. But on one of the holes, they drilled for Spain. It's about 15 millimeters deeper than it needed to be. That is quite a chunk of metal to be missing from one side of the flywheel. And I know we're not building a race engine, but still, I'm going to stick a chunk back in there. Ideally a piece of metal that fits inside the hole, I suppose. Anyway, I cut off a little piece of mild steel. Just put a little bit of epoxy around it. I know this is kind of jank, but this is not my choice, and it'll work. Okay, there we go, that's it. It will now live down there forever. No one will know our dirty little secret. Alright, you missed the action on the first one. Some dodo forgot to press record. Now, there is an easy way to get the dowels out, and had I known the machine shop was going to struggle, I'd have taken them out myself first. You basically just drill from the back and punch them through. I've got another flywheel to do soon, so I'll upload a quick video when I get to that. Okay, so that's good. Those went in no problem. Didn't need the retaining compound in hindsight, but I didn't know that until I attempted to put them in. Alright, next we need to deal with the hole. Now this is a new bushing. Here's the old one. The thing is, when you buy these bushings new, they are more or less the right size, but when you press them in, they go undersize, and you have to open them out a little bit. Otherwise, they won't fit onto the gearbox input shaft. So this needs to be opened out to, I think it's 7/8 of an inch plus half a thou. Here's a little bung I whipped up, and you can see that it does not fit. Almost, but not quite. And what we need is a little bit of gap. So the manual tells us 8755 to 8757, which is what we've got. You would see 0 would be 875, and we're about half a thou, maybe a smidge more over that. Now I have machined the very end smaller, so we know how when we're getting close. So that's about 1 thou under. Okay, and you can see that the very end of it does sort of go in. So it's pretty close to the right size, but it's not the right size. Now this probably won't take very long. And I am running it dry because this is an oil light or sintered bearing. And I do not want to fill it with grinding paste. We'll see, we're almost there already. Okay, there we go. Perfect. It feels pretty good. I do have plenty of these bushings if we mess up, so that's not an issue, but I think think that's as good as we could have hoped for. It's nice and tight, but it goes all the way through. Obviously, the input shaft from the gearbox won't be this tight because it's slightly smaller. This has the tolerance built in. Nice. I'm not actually sure that this is a sintered bearing now that I look at it, but in any case, we'll get some oil soaking into it, just in case it is. Okay, the plan. Well, as I mentioned earlier, I am going to take the exhaust manifold off my engine and put it on this motor. Yeah, I cut that bit out. But basically, in real time, at this stage, the sale wasn't finalised, and I hadn't got around to buying another manifold yet. So I figured I may as well use my one, and if the sale goes through, I'll just replace it. It's not an original from the factory part that came with my motor or anything like that. Oh no! Spillage down here, spillage down here. The other thing I am taking from my engine is the oil filter adapter. And why, do you ask? Because I would prefer to run the original style oil filter. There's nothing wrong with these adapters, but there's also nothing wrong with the original ones in my opinion. So I'm going to put an original one back on my motor and may as well give this to the next guy. Plus I'm too lazy to clean up another filter right now. And we are of course going to run this engine. Now the most convenient engine stand I have is this. It's pretty much built for the job. The only problem is there's another engine in the way. So that's a bit inconvenient, but that's what we're going to do. And that is the reason I haven't taken the manifolds or the oil filter off yet, because I want to start this up and make sure all of the stuff around the engine works before we put the new one in. Now I have had this running within the last day or two, so it should be fine. The problem is if I don't start it for a long time, the carburetor gets gummed up because, you know, new fuel kind of sucks. You get little crystals forming inside the carb, which block up the small ball valves. That wouldn't be an issue if you were driving the car all the time. Obviously it would flush itself out. But anyway, let's make sure all of that works, because the last thing we want to be doing when we put a new engine in is wondering why it won't work. Maybe the carburetor, maybe the coil, maybe the whatever, okay? We want to know that everything around it is good. Okay, yeah, this carburetor needs rebuilding again. I think we better do that in fact. Okay, let's turn it off. Very annoying. I could hear it popping a little bit. That'll be the fuel. We don't want that to be happening when we fire up the new engine and be wondering why. Always a side quest. Yeah, can you see all this green sort of fuzzy stuff? Right here, for example, is a tiny ball valve. You can see that should be closed now, I think, but it's stuck. And probably the jets are clogged a little bit as well. Yeah, look at that. It's like fuzzy green stuff. Anyway, that's not what this video is about. I'll see you back at the engine soon. Okay, one quick carb rebuild later, and we're back. Ignition on. I've also drained the fuel tank and put fresh fuel in. It was pretty old, at least a couple of years. Let's go. That's better. I don't need to run this for long, but I'll just give it a few minutes to flush petrol through the carburetor. So that's it, little fella. You're going to have some bits robbed off you. Don't worry, you'll get them back. You'll get them back. Okay. Manifold time. One exhaust manifold. Good. Okay. Better put some hardware on that just quickly so it doesn't fall on the floor. First thing I can find. No, this is not correct, but just stay there while I go find the correct nuts and bolts and things. And we have a gasket that plops on here. And it's worth putting some exhaust paste on that. You don't have to. I mean, I have had this gasket leak though. Okay, cool. There we go. Now that needs to locate on the dowels, like so. And again, I'm down a bit of hardware, so we're just going to borrow some from me. Okay, there's just a little bit of pressure on the exhaust manifold, because of course the inlet is doweled to the block, so that doesn't move. Sorry, I know I am rushing a little bit. I've got to be somewhere in a few minutes. I want to get this clamped down before I go. So the inlet manifold is now pretty snugly held against the block. It's not tight, but it's snug. The exhaust just has a little bit of pressure on it, so it should still be able to pull up when we tighten these. Okay, there we have it. Looking pretty fancy. So this is pretty much ready to run, apart from the oil filter, because I thought you guys might like to look at the adapter before I put it on. So here it is. Now, I was just going to throw this on with everything else, but from my original series of videos about building an engine, this adapter is probably what I got the most questions about, because everybody wants to know where they can get one. And the answer is, I can't remember. I think Atlantic British, one of the American places. It's often not in stock, but that's where you can get them. They're kind of expensive. Anyway, all this is an adapter to take the Land Rover holes and reposition them to suit one of these standard style filters that you spin on. The other benefit of these is that they have a tapped hole for a standard aftermarket oil pressure gauge. This is the normal Land Rover oil pressure switch, so for the little light on your dashboard. Now, we are going to take advantage of this when we start the engine, so I'll pull this plug out now. I think the thread they use in here is the American one. I think it's 1/8 national pipe thread or something like that. Oh, they got that in there tight, haven't they? Okay, I'll make sure this is really clean and then we'll put it on the engine. And this says top on it, so we'll try and get that right. I've got some Loctite on these screws because we don't want these coming loose. Yeah, these adapters are a little clumsy in this sense. You see, the way that it is, you can't get any sort of ring, spanner or socket or anything on it, so that's the wrong one anyway. Okay. And of course, this filter is only going to be on here for a couple of startups. You know, if I was putting this engine into a vehicle, it would be, what, 100k or so before you change the filter and oil and everything. And I think you can probably use a larger filter. I don't know, you would just have to check where the steering arm is. I think that's what it might hit. This is just the same part that I happened to pick up way back when I got this adapter. I took it into Repco and just found the filter that fit. I don't know, what do we do next? Well, first I've got to get my engine out of the way because I've only got one crane. Oh, there we go. And then get this one off the stand so that we can attach the flywheel and flywheel housing. Get this a little closer to the ground. Don't want to drop it at this stage. I mean, that would be good for YouTube, but not so good for me. Now, you'll note there is no gasket here. That's the way it's supposed to be. I'm actually going to take this off again after we run the engine so I can check for any leaks before I send it off. So I'm not going to put anything on here, but you could put like a gasket compound on here or something if you wanted to. Because I don't know if you can see down here, but it is very crusty here where water seeps in and sort of gets trapped. Hopefully that's enough to get the bolt started. Okay, that's that back on. What do these bolts look like? I must have two left somewhere. And now, oh, the flywheel. This is going to be a little tricky the way we are. Is that it? Now, you definitely need to use Loctite on these. That's in the service manual, not just an opinion. But like I said, I'm taking this off before I send the motor away. So we'll leave the Loctite off for now. 35 to start with, I think. Whatever I set it to. And then 60. The actual requirement is 60 to 65. Since we're taking it off again, we'll go with 60. Okay, I forgot, we also need a clutch. So I've taken care of that. Now let's get this hanging lump of cast iron into this hole. Okay, getting these Land Rover engines in can be difficult. Sometimes it takes a few minutes, sometimes it takes a few hours. First of all, you need to make sure that the clutch is really well aligned with the spigot bearing. I didn't use a special tool for that, just my eyeballs. It's better to use an alignment tool though, because then you know that that's not the problem when things won't go together. Now there's nothing fundamentally different going on here than for every other type of engine. The gearbox input shaft has to line up with the spline on the clutch and the spigot bearing, and the studs on the back of the flywheel housing have to line up with the holes in the bell housing. But I think what can make these engines tricky is that all three of those things are meeting at the same time. It's like another hour later. Let's not even talk about it. And you go, I think it's finally there. So don't get frustrated and don't force the engine and gearbox together. By the way, it's a lot easier with two people, so you can have one person pushing the engine against the gearbox while you bounce things around. But anyway, in the past I've pulled my engine out, changed the gasket and put it back in again, all before morning tea. So it's not always a fight, but sometimes it is. Anyway, we're in. Okay. It's in, properly in. Bell housing bolted up. One engine mount bolted down. The other one's a little bit annoying. Have to turn the spanner over a little bit at a time, so yeah, we'll just leave that one off. It's not going anywhere. We're not going off-roading today. So let's get the various functional parts connected, like the exhaust, a couple of cables, things like that, and then we'll fire it up. And I'm just going to blast through this because this series is about rebuilding an engine, not wiring. But all I've done here is connect the solenoid and the starter motor, and I'm firing those with a trigger. Okay, so from the vacuum advance mechanism on the distributor, up here to the vacuum hose on the carburetor. Okay, that's where this goes. Not down here where the CCV attaches, not over here where the brake booster attaches, okay? And I didn't do the nice copper wound and shaped pipe, which is what these engines originally had on them, because the potential buyer is not going to be running this carburetor. He's got something off an old Holden or whatever. Said it's worked great for years, so that's what he's going to put on it. So this will be different. So there's no point bending up a nice copper line or perfect if it's just going to get mangled and attached somewhere different. Okay? Plus this is pretty neat and tidy anyway. It just needs a P-clip at the back. Now the next thing, which I should have done ages ago and I'm not sure why I didn't. In fact, I think I even mentioned it. Here's the timing mark on the pulley, and we're going to put some, in this case, silver paint because I can't find white. Oh, great. Oh, it's gone everywhere. Because if you don't put something in it, it's really hard to see with the timing light. I've just marked on this piece of masking tape the arc length for 30 degrees. Now, you don't have to do this if you, well, you don't have to do this at all. But what I want to do is just put a little mark. No, we need to go the other way, don't we? At 30 degrees advance. Is there? Because that is where our distributor should advance to. Maximum advance, I think, is actually 34 degrees. And I just want to see if this electronic distributor is actually doing the correct distributor things. That's a very runny mark, isn't it? Never mind. It will suffice. Oh, shoot. Okay, big leak. Thermostat gasket is not gasketing. And you know what? I took that one off. I thought I would get away with just tightening it back up, but it looks like no. This is my fault, not the gasket's fault. When I took the head off, obviously I had to remove this, and it's like a sandwich, right? So there's a gasket further down, and I just took off the one further down and tried not to disturb this one, but obviously I did. Okay, I think that should be sufficiently sealed. It's holding coolant for the time being anyway. Although it wouldn't surprise me if now the bottom gasket leaks, because I just did exactly the same thing which caused the top gasket to leak. Only change one of them. I've got an oil pressure gauge connected. We don't really need this to see if the engine's got oil pressure. I've more hooked this up so I can see that we don't have too much, so that I can check that the oil pump is working correctly. So, okay, let's fill it with oil, I guess. Rather than be a boring normie and putting oil in the oil fill tube, I'm going to fill up the engine via the rocker cover. Oh yeah, we have these funny nuts, don't we? It's much more fun to fill up the engine from the top. Now I'll tell you why you should do this. Because if you fill up from here, first of all we're getting oil all over the rocker gear, but also the oil runs down through all of your tappets, over the camshaft on its way down. And additionally, there is a reservoir on these engines underneath the camshaft, and I'm not sure that that really fills up if you use the oil fill tube. Obviously, if you're just doing an oil change, there's already going to be oil in there, but I mean if you're filling up an engine for the first time. So what we're going to do next is crank the engine to build oil pressure. At this point, I still have not connected the fuel, and the carburetor is pretty empty. Ideally, you don't want to wash your cylinders out with raw petrol. Hey! Okay, good. Now that battery didn't sound the freshest. I probably should have charged it up first. Just been sitting here doing nothing for a while. Okay, just wipe the oil that we poured all over the top of those off. Now what we are looking for is oil to come out of these holes here, because if we have oil coming out of the rockers, we have oil pressure inside the motor. It's going to take a while because we have to fill up the oil filter first, but that's what we're looking for. Come on. Come on, battery, you can do it. I'll go hook up the charger. Alright, it's been nowhere near enough time to charge the battery up, but let's give it another crank. Yeah, there we go. Okay, see the oil coming out? And I saw it on the gauge too. It's great, so we've got oil right through the motor. We've got our fuel line coming from the tank. And it goes. Now this being a Land Rover, we can just pump the fuel up and fill up the bowl. Okay. You can start. Yeah, it's definitely not pumping. It's always a problem, isn't there? I thought that maybe if I pre-filled the pump, that might help get it going, but no. Spilling stuff everywhere. Let's see what happens. This pump is bad. Nothing at all. Bugger. New parts, eh? Well, let's not mess about. Let's get this junk out of here. Get out of here, garbage. Just gonna destroy a bunch of gaskets. Okay, on you go. Just use the same gasket. It's probably going to leak a little bit of oil, but that's okay. This one isn't staying on here anyway. Because A, I need a fuel pump, so I can't just give it away. And B, these original ones, although you can functionally rebuild them, they do leak oil. The little handle thingy where that hinge mechanism attaches, you can only change the seal on that little hand pump basically by destructively pulling it apart. So keep using an old one forever, it's likely you're going to have to just put up with a little bit of oil seepage. Okay, now let's see how this is supposed to work. There we go, see the fuel? See, filling up. Just give it a few pumps to get the fuel up to the carb. Okay, fuel system, good to go. We should have plenty of juice in the battery now. So we'll take my 10-phase mega amp battery charger off. Get you out of the way. All right, well, if you're expecting some big YouTube jumping around moment, it's not gonna happen. I expect this to work. Let's go. Just like that. Okay, our timing is way off. Way off. Screwdriver. Screwdriver, screwdriver. You can see I'm quickly checking the timing here. I just need to make sure it's in the right ballpark so we're not risking any kind of damage. Of course, if you were using a traditional points-based distributor, the timing would already be bang on because you would have set it with the static method. But with this electronic distributor, the engine has to be running for us to have any idea where the timing is. Now remember, if you are setting timing with a timing light, you need to disconnect the vacuum advance. And later, when I set the timing properly, we also need the idle speed to be as low as possible so we're not getting any effect from the mechanical. Okay, now we don't really want it to just sit here idling. All right, oil pressure. Looking good. Top of the motor sounds good. Well, doesn't sound at all, which is good. Got an annoying rattle coming from my exhaust somewhere, but the motor itself sounds good. Thermostat should open in a second, I think. Oh, there we go. All right. Okay, it's getting awfully smoky in here. I'm going to shut it down. I'll be back in the morning. That's it. She's a runner. Over the next couple of weeks, I ran the engine up to temperature a number of times. Of course, there was a leak from the front of the sump gasket, which was my fault. I disturbed the gasket after I installed it. Anyway, once that was replaced, the motor was leak-free. Nothing from the rear main, nothing from anywhere. Also replaced the fuel pump with another one that worked, and after the first proper warm-up I reset the head bolts. I'm not sure that that's really necessary with a modern head gasket, but I did it anyway. And retorqued the sump bolts. Land Rover says to do that after 1,000 kilometers, but I would suggest doing that after you properly warm up the engine for the first time. Adjusted the valve clearances again, and also did a compression check. Mainly because the engine was being sold, just to verify that everything was fine. And that's it. Everything appears to be really good. And the sale did go through. In fact, if you're watching this roughly real time when the video comes out, the motor is probably halfway across to Nullarbor, on its way to Western Australia. A guy called Angus is going to stick it in here, and I guess drive all over the outback. I hope this series of videos encourages you to rebuild your own motor. It's not that hard, and these 2.25 litre engines are very robust and parts are relatively inexpensive. If you're in New Zealand and you do need to rebuild your Land Rover engine but you don't want to do it yourself, you can send me an email. I am intending to have a website with pricing and details, etc. But in the meantime, just send me a message. So anyway, that's it. Thank you all very much for watching. I'll see you next time.